we have a piecewise defined function that has three parts. The first equation says that our function is equal to 4 whenever x is less than -2. So from negative infinity to -2, our function is equal to 4. So this piece of the graph, we're going to go to -2, 4 and put an open circle because it doesn't include the value, and then any value less than that, our graph is at 4. The second part of our graph says that between -2 and 2, our function is x squared. Well, -2 squared is 4, so at -2, I'm going to really be at 4, so I can go back and color in this hole, and so now I do have a value at that point, -2, 2. At -1, my graph would be equal to 1. At 0, it would be 0. At 1, my graph would be equal to 1. At 2, my graph would be equal to 4. So the middle part of this graph is that parabola. And then the final piece of my graph says that from 2 to infinity, my graph is also equal to 4, the y values are. So from 2 to infinity, and I already have an ordered pair filled in at 2, 4, I'm going to remain at 4 for the rest of my function, all the way to infinity. So here I have a piecewise defined function that turns out to be continuous, because at the places where it switches rules, we have the same y value. So a piecewise function can turn out to be a continuous function.